Example 1 of indefinite of improper integrals. All right, determine whether the integral from 1 to infinity of 1 over x closed dx is convergent or divergent. According to part A of definition 1, we have the integral from 1 to infinity of 1 over x dx equals the limit as t approaches infinity of the from 1 to t of 1 over x dx equals the limit as t approaches infinity, the limit of the absolute value of x, open bracket, from 1 to t, the limit as t approaches infinity of the natural log of t minus the natural log of 1 close equals the limit as natural log of t approaches infinity. That again is the limit as t approaches infinity of the natural log of t equals infinity. The limit does not exist as a finite number, so the improper integral from 1 to infinity of open 1 over x closed dx is divergent. Let's compare the result of example 1 with the example given at the beginning of this section. The integral from 0 to infinity of 1 over x squared dx converges. The integral of 1 to infinity of 1 over x dx diverges. Geometrically, this says that although the curves y equals 1 over x squared and y equal 1 over x look very similar for x squared than 0, the region under y equals 1 over x squared to the right of x equals 1, the shaded region in figure 4, has finite area, whereas the corresponding region under y equals 1 over x in figure 5 has a finite area. Note that both 1 over x squared and 1 over x approach 0 as x approaches infinity, but 1 over x squared approaches 0 faster than 1 over x. The values of 1 over x don't decrease fast enough for its integral to have a finite value. Figure 4, the integral from 1 to infinity of 1 over x squared dx converges. In figure 5, the integral from 1 to infinity of 1 over x dx diverges.